Alright guys, this is an add-on to Note 20. We're going to figure out if a function is odd or even looking at the draft only. So let's go. Hey guys, and welcome back. So in my last note, I talked about even and odd function and how to figure out whether they were even or odd, looking at their algebraic expression. And so this time I'm going to do the same thing, but we're going to be focusing on their draft alone. And so as you know already, a basic function like x squared would happen to be an even function because you have an even power on the x variable. And so if I were to show you the draft of x squared, this is what it would look like. This is simply going to be a parabola. This function happens to be even because opposite values of x would get the same y value. In draft term, formally, you will know that the function happens to be even if the function is symmetric with respect to the y-axis. And so you can see here, if you look at this y-axis as a mirror, you can see that the function f of x is reflecting to the y-axis perfectly. And so that's what makes this function an even function. And so let me give you another draft here so you can see exactly what kind of functions are even. And so I'm going to have here this particular draft going up, and then down. And so you can see here that, again, if you look at the y-axis as a mirror, this draft perfectly reflects through or with respect to the y-axis. So this draft is the draft of an even function. For odd functions, we figured out that basic functions like x to the power of 3, which are x raised to the power of an odd number, happen to be odd functions. And so if I show you the graph of x to the power of 3 here, this is what it would look like. It would look like a curved line going through the origin. And so to figure out graphically if a graph happens to be representing an odd function, all you have to determine is whether or not the graph is symmetric with respect to the origin. What that means is every point on the graph can find its reflection through the origin to be also on the graph. So basically, every opposite x value would have opposite y value as output as well. And so you can see here that that's the case, where this x value would have for output y, and this particular negative x value here would have for output negative y. And let me give you another graph here to make this concept just sink in. So if you have a graph that went up, down, then up, and as you can see, every point on this side of the graph, if you made a straight line going to the origin, you would reach another point on the graph on the other side. So this graph is symmetric with respect to the origin, so it is a representation of an odd function. Okay, now that we have seen examples of even and odd function, let me give you examples of functions that are neither even nor odd. And so the first example here that I'm going to draft is this particular one. As you can see here, this particular graph here is going through the origin, but it is not symmetric in respect to the origin, nor it is symmetric in respect to the y-axis. So this particular graph here is actually neither even nor odd. And if you look at the algebraic expression for this particular graph, which I know happens to be h of x equals to negative x squared plus 2x, you can see that this algebraic expression is made out of even terms and odd terms. And as you know from my previous note, whenever you have odd terms and even terms making up a particular function, then that function will happen to be neither even nor odd. Right? And so this particular graph here represents a function that is neither even nor odd. Let me give you another example of a function that's not even nor odd. A graph that goes up, down, up like this. This is definitely not odd, and it's not symmetric with respect to the y-axis, so it's not even either. The vast majority of functions are actually not even nor odd. They are just functions. The last thing I want to show you is this last graph. So if I draw this particular circle centered around the origin and have a radius of 1, this particular graph, as you can see, it is symmetric with respect to the y-axis, and is also symmetric with respect to the origin, because every single point on the graph we find is opposite also on the graph on the other side. If you have a graph like this that happens to be both even and odd, you should know that this graph does not actually represent the graph of a function, period. So you cannot have a function that's odd and even at the same time. That doesn't exist. A graph represents a function if it passes the vertical line test. And as you can see here, or as you can tell, this particular circle fails the vertical line test, as if I draw a vertical line here, you can see that it cuts the graph at two different places, which means that this particular x input has two outputs, which is more than one, which is not good for functions. So basically, you can have a graph that is both even and odd, but that graph is not going to be a representation of a function at all. And so with that, next time I'm going to talk about piecewise function and how to draft them. See you then. Bye-bye. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.